Hey, it's David. I'm a math tutor at Purdue. I saw this on Reddit the first week of classes. It's Math 162, and the question is about a three-way tug of war with vectors. It says three people located at A, B, and C pull ropes tied to a ring in the center. Find the magnitude and direction of the force with which person at C must pull so that no one moves. The system is in a static equilibrium. And the drawing given looks like this. Someone at B is pulling 30 degrees from center with a force of 60 pounds. And then someone else is pulling diagonally 45 degrees left of center with a force of 100 pounds. And then we're going to be at C pulling, what was that, southwest, with some unknown force, F3, and unknown angle, alpha. And our job is to find how to cancel out all three of these forces together. So the thinking is, if you look at the horizontals left to right, it looks like the person B is pulling to the right, whereas person A is pulling to the left, and C is also pulling to the left. So we're going to try to even out those left and right forces, make a perfect match. And let's see what those are. The right force is, we're going to complete this triangle that's 60 hypotenuse and 30 degrees. We could say that the adjacent going right is 60 times the cosine of 30 degrees, which should be root 3 over 2. You have that major angle memorized. And then on the left side, we've got the 100-pound force at a 45-degree angle. So the horizontal left pointing component would be 100 times the cosine of 45 degrees. So that's 100 times root 2 over 2. And what's toughest is that last third triangle C, is we don't even have the magnitude nor the angle. And so we're going to just leave that as an unknown and say that F3 is the hypotenuse times an angle alpha cosine would give us the horizontal. And then we'll solve for that later. So by algebra, we can say that we're going to solve for this F3 cosine alpha by moving the 100 root 2 over 2 to the other side and take that difference. So we'll simplify. The 60 over 2 is 30. And then the 100 over 2 is 50. And this is basically our horizontal component of the C triangle. That's what we're going to need to point left. And then next we can do the verticals. Since A points up and B points up, C needs to point down with the same vertical component size. So let's put the ups, the north vertical components, on the right. We would say that, looking at person B, they've got a force of 60 times a sine of 30 degrees, and sine of 30 degrees is 1/2. And then person A has a force of 100 and an angle of 45 degrees. That's a sine of 45 degrees is root 2 over 2. So this must be matched by the south component vertically of the third person C, which is F3 sine of angle alpha. And this basically is what the components of that bottom third person triangle are. Have that vertical, I mean to point that all the way over here, and then the horizontal that we found first is down there. And so with that information, you can find the size of the force with the Pythagorean theorem. It's ugly looking, but you can think of this first horizontal component as like an A, and this second vertical component is like a B, and you can say A squared plus B squared equals C squared. And then with the Pythagorean theorem, you plug in those numbers, square them, add them up, and then take the square root of the total, and you're going to get that the third force is around 102. And later, if you needed to find the angles, you could take the ratio and say that, F3 sine alpha over F3 cosine alpha, that would simplify to make sine alpha over cosine alpha is tangent alpha, where the F3's on top and bottom cancel out. So we would ultimately get something like, if we can carry this over, F3 sine alpha over F3 cosine alpha equals, slash out those F3's, that's tangent alpha, but we have those numbers before. The F3 sine alpha on top was the 30 plus 50 root 2, and then the cosine, F3 cosine alpha, was the 30 root 3 minus 50 root 2. And so if you took the tangent inverse of each side, you could say that alpha is tangent inverse of that quotient, that ratio. You plug that into a calculator, and you get, one of the major angles between -90 to +90, which is quadrant 4, quadrant 1. But since this has to point southwest, you can just make an adjustment using symmetry, and that's how you find the angle.